All right, good day, everybody. My name is Jason Strait, the one of the leads for the Cloud Pass Virtual Group. Today's presentation is Azure Intelligence Services, being presented by Amie Mason. Before we hand things over to Amie for her presentation, I just want to go through a few announcements. To start with, this webcast is being brought to you by Quest. Quest has their Spotlight Cloud that provides the first Azure-hosted database performance monitoring solution focused on SQL Server and its customers. It gives you the ability to just leverage scalability, performance, built-in security. It uses Azure, Cosmos DB, and basically gives you the best of the cloud with Quest engineering insights that they've been developing for years and years. So if you are looking for any performance monitoring tools for your SQL Server or data platform environment, I encourage you to check that out.
Okay, and I just want to make sure that you guys can see this screen here with the title page for the presentation and not my others.
Yep, you've got the right one up. I can see it.
Great. Awesome. Well, thank you for that lovely introduction. So what we're going to go through today is an overview of the AI-related services in Microsoft Azure. To get you guys familiar with me, I am the practice lead for data science and analytics at Atunix. And Atunix is a consulting organization, so professional cloud services, solution implementation type consulting organization. We're headquartered in Bellevue and Redmond, so right there next to Microsoft. I'm personally based in Phoenix, though I'm in Boise right now for work. And at Atunix, we have very good partnerships with Microsoft, obviously, but we also do work with GCP and AWS. At Atunix, we have several different practices. So we have modern data center, application modernization, IoT, and then the practice that I'm part of, which is our advanced analytics practice. Obviously, my team does data science and analytics, so visualization, reporting, BA, things like that. And then the other side of our practice does data platform and big data. So that's a little bit about me. Normally, when I give this session in person, I like to ask a little bit about you from the perspective of where you are in your analytics journey as an organization. So as a consultant, I meet with lots of different companies at different points along that journey. And so I feel like this visualization that's on the screen right now does a good job of level setting and getting people to understand not only where they are, but where they could possibly go with the things that we're going to talk about today. Obviously, lots of organizations, especially those that are smaller, start out with at the bottom there with static reports, things that are going in Excel that basically can only tell them what happened in the past. And the main point here that I want to get at is there's a large manual process there to really be able to make any decisions for your business and ultimately impact your business, which is the whole point why we gather data. We don't just gather it to pay for storage. We gather it to have an impact on the decisions that we make to move our business forward and make us successful. So as we progress through this hierarchy, we're going to be focusing on the top two tiers there today with predictive analytics, getting us looking forward with our data and how we can ultimately get to the point where we're better supporting and even automating some of that decision-making process. So I'll let you guys think about where you are in that process rather than talking to me about it. So the way that I'm going to go through this presentation today is I'm going to talk just a little bit about some of the things that we see our customers doing about and with AI and machine learning in general. We'll talk about the services that are available in Azure and how they can work together to give you a really great scalable architecture for your data science or AI-related endeavors. And then we'll jump in and do some high-level demo of a handful of those tools. Nothing too deep, but should get you moving in the right direction and at least know what things look like and how to use them. So I always include this slide whenever I'm having a conversation with anybody who's just getting ready to enter into their machine learning or data science efforts. And I do it because right now people like to really throw around the term AI and it really is used as a catch-all. And so if we focus on the blue oval up there in the top right, AI includes a lot more than just machine learning. It can be any of these bot type interactions, but the gist of it is any technique, whether it's predictive or not, so using data science or using rules-based processes or decision trees to mimic something that a human might normally do, so some kind of a decision-making process. And then within that, there's machine learning, and that's where your statistical techniques or your air quotes here, math come into play. And then deeper than that is obviously deep learning, and that's where you're really looking at scaling and doing some of the deep learning techniques with the available frameworks, such as TensorFlow and Keras, and where the neural networks really come into play. So that's when we're looking at a lot of data and really, really complex multi-layered processing. So that's that at a high level. And then so jumping into some of the industry trends, at Atunix we work with a lot of customers in the realm of AI. Everything again from implementing a rules-based process in a bot that enables some kind of an interaction between employees and customers, or really whatever you need to do, all the way through to processing for complex manufacturing, production optimization, to product recommendation, pricing optimization, things like that. And it's not just one industry that's doing it. We have clients, and we're really seeing it at all levels, large organizations to small regional companies. So it's really, really great time to be moving forward with that type of engagement. Again, a lot of what we're seeing falls into these buckets that I've put here. So there's a really big push on customer engagement. And so that could be anything from targeted recommendation models for products. It can be marketing, targeting, anything to do with customizing something for your customers. But also it can be those bots that I was talking about, and we'll get into how Microsoft can help you with that. But simply putting a automated chat bot, live chat type scenario on your website, that's been extremely popular over the last year or so. We do a lot with predictive maintenance. If you were to go look at anything and just Google Azure, interesting, my Teams is closed, sorry about that. But there's a really good example that Microsoft has for predictive maintenance. It's a Rolls-Royce case study, so if you're interested in more information on how that can work, that's a really good one to look into. Inventory optimization across all different types of retail and manufacturing companies. Product recommendation. And product recommendation, it's interesting. We're seeing it similar to what you might see on an online retailer, but as well as something that's for the sales team going out and face-to-face making a recommendation in a cross-sell, upsell type manner to their clients. Help desk scenarios, very similar to the live chat on the website, but internal facing, so we see a lot of that as well. Identifying leads and targeting or prioritizing those leads. And then I say fraud detection here, but it's not just fraud detection like you might think of in a credit scenario, but there's a lot of anomaly detection, like in healthcare claims processing and things like that. And I'm sure that you guys are thinking of plenty of ways that machine learning, predictive analytics could really impact your business. And there's a lot more than just this going on right now, but these are some of the top things that we're seeing at Atunix. So the obvious question becomes, what can I do, or how do I get here? And so we'll talk about how using the Azure services that are available, we can accomplish some of these things. So what we're looking at here on the screen is, it's called the Azure or the Cortana Intelligence Suite, and it's a selection of services that are available in Azure that really support AI workflows. And they're not specific to AI. They're used for a variety of things, but these are the ones that, if you are engaging on a machine learning or AI project, are more than likely what you're going to be using. So overall, obviously, as we said earlier, we're looking at taking data from a variety of sources and doing something with it. We need to get it in the hands of the right people in the right format, so that way we're able to take action on our data. And so that's the left and the far right and the orange and black there. And let's focus on these 4 blue columns. So at a high level, this process is broken into these four phases. When we get our data, we need to be able to manage it, get it into Azure and manage it appropriately. We need to have some kind of an efficient and scalable storage. Then we need to do the fun stuff with machine learning and analytics. And then there's this overarching intelligence capabilities that are available. And the particular thing about those is with cognitive services and bot framework, you actually don't have to write much code. It's already written and packaged nicely for you. And then Power BI, we're seeing a lot of Power BI development, and Power BI being used as the as the tool that's surfacing this information to our business users. So in Azure, for connecting to data, we're going to be talking about Data Factory. So Data Factory, we used to think of it as SSIS in the cloud. And with V2 of Data Factory, it actually supports SSIS packages inherently. So if you're already using SSIS, you can easily transfer into using Data Factory in the cloud. But beyond bringing that data into Azure, it also acts as a data movement tool or data orchestration tool inside of Azure. So not only does it bring your data from on-prem or wherever else it is, if it's in another cloud service, into Azure, it also moves data between services in Azure. With Data Factory, we also kind of make a change from a traditional ETL process to where we're thinking more ELT. Because of the services that are available in the cloud, it's much easier and efficient, and there's a lot of benefits, especially with respect to machine learning, for extracting that data, landing it somewhere like data lake or blob storage in raw form, and then transforming it and staging it into something like a SQL data warehouse or a SQL database. Gives you a lot of flexibility, and it's a bit cheaper too. So it's Data Factory. Data catalogs and metadata catalog, we see that being used a lot with our data warehousing implementations, but also with respect to Power BI and machine learning efforts or data science efforts, because it allows you to register data sources wherever they are. Azure on-prem allows you to tag them appropriately, give you information about what models or what visualizations or what projects are using that data, so that way your users can come in, search for the right data, and really get access much quicker. So that's a great tool. We do a lot with Power BI, which I know isn't the focus of this conversation, but there's a lot of interest in Power BI right now, and Power BI and Data Catalog pair well together because you can register a Power BI data set as an asset, and then from Data Catalog, your business users can open up a Power BI desktop file directly from there and get working. Event Hub, that's going to be for streaming data. So if you have any real-time sensor data coming in, we might not be using Data Factory, we'll be using Event Hub because of the speed at which it can process that data and get it where it needs to go. I believe it processes something like 500,000 transactions per second. So it's pretty scalable. So that's that first column. The second column under big data stores, I mentioned data lake storage. It's regular data lake architecture, just Azure's version of it. There is no limit to the amount of data that you can store in Azure Data Lake. And so it really plays a central role in most of our architectures, which we'll show you. I have a couple diagrams for what our architectures look like. But we'll store the data there, and then our data scientists will be able to come there, access the raw data, and then we may have a data warehouse coming off the end of it to model the data relationally for other purposes. But a lot of times a data scientist is looking to access the raw data, and so it gives them the ability to go back to Data Lake and get that data. Azure SQL Data Warehouse. So Azure splits out a data warehouse from Azure SQL Database. So Azure SQL Database, very similar to what you would experience in traditional SQL Server, whereas Azure SQL Data Warehouse is parallel processing. So it's highly scalable, very fast. And the great thing about Azure SQL Data Warehouse is you can spin it up, do that very, very high level of processing very quickly, and then pause it so you're not being charged for anything when you're not actually using it. And so we have some clients who do that, use the SQL Data Warehouse to do all their transformations and then push that data out into an Azure SQL database and then use the database for connection. Cosmos DB, pretty straightforward. That's globally distributed database, really great for big data and application data. Blob storage, similar to Data Lake, but there's limits there. So if we're dealing with a small situation, small amount of data, we'll use blob storage. Otherwise, most of our architectures do use Data Lake. I'm going to skip the third column because that's kind of where we're going to be focusing for most of today. And so in that fourth column, I mentioned that cognitive services and bot framework are basically built out for you. And so a lot of times if you're wanting to do something with data science or machine learning, you need to have a data scientist. Not everybody has that type of a resource, but you might have an application developer, someone who can write a wrapper to call an API. And so we'll talk about the cognitive services. They're basically pre-trained machine learning models that you can use to do a variety of things. And so we'll demo how you can use that in some other Azure services to do some text analytics, so sentiment analysis, topic tagging, things like that. And there's more that you can do with cognitive services. We'll come back to that. Bot framework enables that conversational experience in a chat bot effectively, and the bot framework's all built out, so you don't have to build it out yourself. You can use the bot framework in combination with cognitive services to do things like text-to-speech type interactions. So there's cognitive services that will take spoken language, translate it into written text, so that way the other APIs can understand that text and then surface it back to you in spoken language, going back in the reverse. So there's a lot that you can do. That one's pretty popular. And then obviously there's Power BI. Unfortunately, we're not focusing on Power BI very much today, but it integrates very well with all these other Azure services. So whether you need to connect to one of your big data stores to pull data or read in data from some of these machine learning or analytics services, Power BI is great for surfacing data to your end users. Pardon me one second. As I mentioned, I've been a little sick, so needed to take a sip there. I'm going to lose my voice. Coming back to this third column of machine learning and analytics, there are a bunch of different services in Azure related to that. And so I'm just going to start at the top and work my way down. This doesn't necessarily mean simple to complex or anything like that, but in Azure there's machine learning, Azure Machine Learning, and there's two services associated with Azure Machine Learning. There's Azure Machine Learning Studio, which I refer to as the baby of machine learning in Azure. We will take a look at Azure Machine Learning Studio. It's great for testing out a concept or proving out a concept quickly, or if you're working with a very small amount of data on a small scale. Most enterprise organizations don't use Azure Machine Learning for anything other than rapid POC development because there are issues with scaling and performance. But again, great tool for someone who doesn't know much about data science, someone who's not fluent in R or Python, to come in and be able to do some of these things or quickly prove out a concept without making the investment and doing some of the larger efforts. Azure Machine Learning Service is really great because it basically provides you with the support to manage your entire data science workflow. So there's a great DevOps piece there. It supports Azure notebooks, which are effectively Jupyter notebooks, but hosted in Azure. You can deploy from ML Studio these models. You can run them on any type of compute from Azure. And then you can set up the ML service pipelines to orchestrate the entire process. So we'll take a look at that at a high level, show you where those things are, so that way you can get familiar with it. Data Lake Analytics, that's going to be Data Lake Analytics uses USQL, which is a combination of a couple other languages, so that way you can do some relatively basic transforms on data in Data Lake Store. So that way there's no need to move the data in and out the way there would be if you were using any of the other services. We use Data Lake Analytics mostly to do basic data cleansing and transformations on the data prior to it being pulled out into any of these other services. HD Insight is Azure's Hadoop. So there's Hadoop, all the other related services, Spark, the Hive, Pig, all of that is wrapped up in HD Insight. They do come as individual services in Azure, but it's basically Azure's stab at those services. We don't use HD Insight a whole lot unless a client is coming from that specific background and maybe migrating from on-prem into the cloud, because we tend to use Azure Databricks instead. And so Azure Databricks gives you all of that effectively from the Spark perspective, but in a very easy to manage environment. And so if you're familiar with managing Spark, for example, I think you'll be really excited about what Databricks brings from a management perspective. I skipped over streaming analytics, but what that is the ability to do machine learning on data as it's streaming real time through your architecture. So if there's any need to do something like predictive maintenance as the data is coming through, that would be the tool that you would want to take a look at. Some of these other tools could do real time as well, but that's exactly what streaming analytics was built to do. Azure Analysis Services is, it's SQL Server Analysis Services tabular in the cloud. So for those of you that are familiar with tabular cubes, that's exactly what that is, but as a service in Azure. So we use that a lot, so that way we are really maintaining a single source of truth in our data warehousing projects. So we'll have an architecture with a SQL data warehouse or SQL database, and then we'll push that model out into Azure Analysis Services, build out all of our dynamic measures and other calculations, and then connect to that in Power BI or whatever visualization tool is being used. Really great for enterprise deployments where you have a lot of people who are used to presenting the same type of data, and it basically eliminates the whole one person having one version of a calculation and one person having another version of the calculation. And then the last thing I have on there are data science virtual machines. So Azure hosted VMs, variety of different types of compute, give you lots of options for scaling your model development and training in Azure, and works great with Azure Machine Learning Service because, again, you can identify which compute resource you're wanting to use. And so when we're testing scalability or doing some baseline testing in Azure, we'll spin up a handful of different data science virtual machines at different levels of compute, or different types of machines in general, and we'll test the performance in order to determine which one's going to be best for our production deployment. So double tapping on the Azure specific services, and I mentioned that there's the cognitive services. So these are those pre-trained models. There's APIs for vision, for speech, for language, for enabling search, and then the text analytics API that we're going to be looking at today. All of the Azure services, the data science virtual machines, they all support the most popular deep learning frameworks such as TensorFlow, Keras, and so on and so forth. So it's great to be able to leverage those without having to come up with something on your own in Azure. We mentioned these services that are available with Azure Databricks, Azure Machine Learning, and then the different VMs that are available. And it's all based on some really powerful infrastructure. Again, CPUs, GPUs, FPGA, depending on what's required for your scenario and to make it most performant. And then there's a bunch of different ways that you can deploy. We can deploy on-prem to the cloud and on the edge with a couple different services that we'll get into when we look at some of the architectures. So looking at the cognitive services that are available, the main point that I want to lay out here is while these are pre-trained APIs, some of them can be customized based on your training set. So one example I like to use is we did some sentiment analysis and topic tagging on airline surveys for one of the major airlines. And if we think about just the simple concept of a flight attendant, if we were to train on the standard dictionary that the text analytics API uses, that would register as two separate words, flight and attendant, whereas obviously we want to be able to customize our dictionary and recognize flight attendant for what it means to the airline industry. So using that as an example, you can do various levels of customization with certain cognitive services APIs that are available. I like to include this slide for the data science virtual machines because these VMs come with so much already installed, updates are managed, all of that for you when you deploy this VM. So it's a great place for your data scientists to come and collaborate, use these data science virtual machines to collaboratively develop whatever it is that you're working on. Multiple tools and languages are supported. Again, those deep learning frameworks come. The R and Python packages and libraries are already there, ready for you to use. And then the various visualization tools are already installed. It's basically everything that you could use in respect to data science right there for you, and all you have to do is go provision the resource. So very, very helpful. And again, these data science virtual machines, they can be based on CPU, GPU, or FPGA for processing. So lots of options for scaling in Azure. So I mentioned that I have a couple of different architectures out here. Each of them I just grabbed related to Databricks. So you'll see Databricks referred to here, but know that it doesn't have to be Databricks in this architecture. It could be a data science virtual machine being run through Azure ML Service. It could be Spark. It could be something else. But again, the idea is as we're connecting to your data, pulling that in. Again, this data warehousing scenario, using Azure Data Factory, dropping that off in either blob storage or this could be data lake. And in this scenario, we're using Azure Databricks to do some of that processing and pushing that to be modeled in Azure SQL Data Warehouse, throwing the tabular model on top of it, and reporting in Power BI. Very, very common architecture, at least from what we see at Atunix. Regardless of whether Databricks used or not. So we do a lot that doesn't use Databricks in the scenario as well. But when it's needed, it's really great to have it there in Azure. For big data scenarios or doing some of the machine learning on big data, very similar architecture, but we're bringing in Cosmos DB for some of that data to manage it for what we're using in our apps. And then for real-time analytics, I mentioned that that's where event hubs would come in. Databricks could process streaming data as well, but you could put Azure Stream Analytics in there. And so these three are just examples of potential architectures using the Azure services available for the AI and related workflows. Two other things I like to call out. So deploying these models once we have them built is really easy, and there's two primary methods that we'll use. We can deploy using Azure ML Service, which again you can manage the entire workflow from training, building that model and training it, to developing the Docker image for deployment, registering that, and then deploying it either in the cloud, on the edge, wherever it's most appropriate. And then there's built-in monitoring for your model as well in Azure ML Service. Other scenarios, you can also deploy a machine learning model in Azure Data Factory. So I mentioned it's a data movement and orchestration tool as well. So you can develop an Azure Data Factory compute pipeline, identify where your training data is or where your input data is, build out your model in Azure ML Studio, Databricks, wherever it be, and then string that together with an output location, and you have a workflow built in with an Azure Data Factory compute pipeline. And so that's kind of what that would look like. We're not going to actually jump into Azure Data Factory to build that out today, but it gives you an idea of things you can do using that tool. Before we get into demoing the tools, I like to leave people with how we approach the AI or advanced analytics lifecycle. It's a very common question we get, so I like to throw this slide out there. And I also like to note that anything that you're doing with respect to machine learning or analytics can only be as good as the data supporting them. So it's very important to make sure that you are collecting the right data, cleaning that data, and looking at it in the right way. It's less than ideal and almost less than realistic to just provide a data scientist with a data set and say, solve this problem. Much easier if we're able to go through more of a realistic process, starting with a business assessment where we're able to work with people who understand the data from a business perspective, understand how we can look at this data, really supports building out some of the features that may support the model later on. And of course, that's going to depend on which approaches you're taking, but it's really helpful not only for the data scientist to understand more of the business problem to really get you a solution. So we like to have that type of a conversation so that way we can get to know you, know what you're doing, and understand your data. And then we move into this proof of concept phase effectively. That's where we're actually gathering the data, cleaning it, enhancing it, doing that feature engineering, testing out multiple algorithms to determine what's actually working best for your data, and then starting the cycle of evaluation and update on that model. So that's an iterative process until we get to a point of being happy with the model and ready to move forward with it. Sometimes you realize, hey, this really isn't going to go anywhere. I'm not seeing any levels of accuracy that I deem acceptable. And then you go address another problem, maybe get new data, bring it in, what have you. Then we move into a pilot. The pilot's really focused on proving impact for the business. So we've proven that this model is statistically accurate in the proof of concept, but the pilot's based on how are we going to integrate this into our existing business process? How are we going to incorporate this into a certain tool we may use? And then is the output of this in a format that is consumable by our organization, by our business users? So that process, anywhere from 6 to 12 weeks on average. We do have clients who pilot for a year. It really just matters what exactly we're working on, what the existing business process is, and how much buy-in we need to get. And then we move to production. So that's where the model's running. There may be running in production. It's deployed. It's automated. There may be a feedback process implemented there. And then there's always this continuous improvement process. There's always additional data you could bring in, additional features you could create, ways to improve the model. So it's really a cyclical process. All right, so let me jump out of here. I am going to show you again at a high level some of these tools. Let me grab this one and bring this over. So first thing that I want to do is show you ML Studio and how you can use the cognitive services. So what we're looking at on the screen right now is Azure Machine Learning Studio. Again, the baby of machine learning in Azure. What's great about it is I can I can have absolutely no understanding of Python or R and be able to come in here and use the toolbox that's provided on the left over here to string together a machine learning model full with cleaning the data, preparing it, creating any features, splitting that data, doing some A/B testing with different algorithms, and evaluating the accuracy statistics at the end. And then I can also, when I'm happy with that, I can then publish it as a web service in a matter of clicks. Again, there are some scalability issues. So for most enterprise production scenarios, ML Studio is probably not where you want to be. But I figured it was great to demo this tool really quick, give you an idea of what these modules look like and how you can string them together. And then also it shows the cognitive services. So what we're looking at here is, again, that text analytics cognitive service. So in ML Studio, I can write R, I can write Python, I can write SQL. And so we're using Python here to call the text analytics API. I do have to have the text analytics resource in Azure, so that way I can get the access key and the endpoint. So you'll see here that I've updated this logic to the region where my text analytics resource is in Azure, and then my API key right here. And so this is basically calling that service. The input for this model is going to be, I'll show you the cleaned version, but we basically have 10 rows of text, and I know it's a little clunky the way that it's visualized here, but we have 10 separate rows of text that we're going to feed into this text analytics API, and we're going to get back a sentiment score. And so we have those different snippets here. And then I've already run this. I like to run the demos beforehand. You'll see these green check marks. And then the output here from running that API is going to be sentiment scores. And so we have 10 corresponding sentiment scores that we could then pair up with the input and present in however we want to. That text analytics API also will do topic tagging and a couple other things depending on which endpoint you use. So very quick intro to ML Studio, an example of how you can use Python to call those cognitive services. And again, there's a variety of cognitive services that you can use, and use the Python SDK to call in Azure or otherwise. I also wanted to show you guys ML Service. So in Azure, we would have an ML Service workspace. And then you can open up the ML Service workspace from the Azure portal. And so let's go ahead and open that up. Here we go. Of course, it wants to be slow when I'm actually demoing it. All right, so I actually don't have anything in this subscription for ML Service, but I wanted to show you the different pieces of it. And then there's a lot of documentation in here, so if you want to get in and play around with ML Service, you can. But the idea is that in ML Service, it provides you with a great collaboration tool for multiple data scientists working together, and you can build out these full deployment pipelines. Great DevOps tool for managing all of that. So I can manage my Azure notebooks, which again, Jupyter notebooks, but in Azure. I can open those here. So you see Jupyter notebook. I've got my kernel identified over here. Obviously, it's not running anything right now. And then there's a bunch of different sample notebooks that you can use and run in here. And then the great thing about ML Service is that you can identify which compute you want to be using to run those notebooks. I don't have any compute in here again, but this is where any of my data science virtual machines or other compute resources would show up. Any of the models that I've trained would show up here. Any Docker images that I create, any full deployments, and again, all of that's going to be orchestrated here with pipelines in Azure ML Service. So this tool, again, great for managing the entire data science process, leveraging Azure notebooks in Azure. And then the last one that I wanted to show you is Azure Databricks. So again, another Azure resource that you would provision. In Azure, you can directly from the portal launch the workspace. And so when I launch the workspace, I come to this screen here. Those same Azure notebooks can be run on Databricks the same way that they could on any of the data science virtual machines. Just depends on whether you're going to be needing serial processing with the data science virtual machines or parallel processing with clusters in Databricks. So I can have notebooks. Again, here is one of the notebooks that we've been working on recently. Let me see if this wants to let me open it. All right, so you can see, I know this is getting a little kludgy, but the point is I can take a notebook from either ML Service, put it into Databricks, put it into ML Service, and run it where I need to run it. The best part about Azure Databricks is actually managing your clusters. So I don't have any running here because I recently deleted them for demo purposes, but to create a cluster in Databricks, it's really, really easy. I would just name it. I can identify which Databricks runtime, which Python version. I can identify my worker type, my driver type, how many workers I need. But the great part is this auto scaling. So if you can imagine scaling in Spark, manual process or something that you have to script out, Databricks can do it automatically. And then this auto terminate after a determined period of inactivity. This is great. I don't know how many of you may have forgotten to turn off a Spark cluster in Azure or otherwise, but these two are the key services or key capabilities in managing your clusters in Azure that I think are most appealing to going the Databricks route. I'm not going to create a cluster because I don't know that it would be done provisioning by the time we were done with our session, but this is what it looks like. This is where you would do it. Pretty great tool. So those are the 4 things that I wanted to show you, again, very, very quickly in Azure. Hopefully that gives you an idea of where you can do certain things. And that's that. So I don't know if we have any questions in the chat window. I know I went a couple minutes past where I was supposed to, so definitely want to open it up and give you guys the opportunity to ask any questions, and I'll do my best to answer them.
All right, great, Amy. We don't have any questions in the chat, and the Q&A is empty at the moment. Seeing if give people here a chance to ask questions if they do. Well, none have come in yet, but while we're waiting to see if one comes in, thanks for presenting here today.
Sure.
Every time I see anything new on any of the AI front or anything like that, it just reminds me how far I've fallen behind since I've shifted over to doing more of the just transactional stuff in anything that I use Azure for. And it's just amazing how much it's changed over the last couple of years.
It's quite a bit to keep up with.
It is.